Okay, so today we're going to derive arctan x. And the first thing that we're going to do is we're going to just let that equal y. We're going to let that equal y because then we can write down the inverse relationship. So we're going to let arctan x equal y. Well, the inverse relationship states that tan y is x. And we can use this, implicitly differentiate it, which means to differentiate both sides of it separately, and then get dy by dx on one side and solve for it, because dy by dx is the slope of the tangent line. Well, we can use this to do that. So we're going to just take the derivative of both sides with respect to x, which means we're going to have a chain rule right here. And we're going to have just 1 on this side because the derivative of x with respect to x is just 1. So we're going to have a chain rule here, d by dx of tan y. Well, I'm going to do that work on the right hand side. Okay, well, when we have a chain rule, it's because we have a variable mismatch, right? We're deriving tan y with respect to x. Well, tan y is a composite function. It's tan x composed with y. Well, that means that this is our outer function, f of x, and y is our inner function, g of x. You don't have to use f and g notation. You can use other letters. It doesn't matter, but I prefer f and g notation. So we're going to write down f of x is tan x, and we're going to write down the derivative of tan x because we need to apply that to the chain rule. And the derivative of tan x is secant x squared. And then we're going to write down the inner function, g of x is y, and the derivative of g of x is dy by dx. This is our slope of the tangent line. This is our slope of the tan line. That's important. This is what we are solving for, right? It's the change in y over the change in x. Well, let me just bound our notes over here. Let's apply this to the chain rule. In fact, let me write the chain rule down too, just as a refresher, because it can't hurt to write the chain rule down as many times as possible. Well, so we have f composed with g of x. And when we have f composed with g of x prime, we use the formula f prime of g of x times g prime of x. Well, we have all of the components we need for that. So let's just apply it over here. This is going to become secant x squared, except that it's not x, it's actually going to be y because the inner function is y. Excuse me. That's going to be y, so secant squared y times dy by dx, which is not a fraction. Just remember that is not a fraction. We aren't dividing dy by dx. This cannot be multiplied by the denominator and then you end up with dy equals something times dx. This is not separatable because this is what we're solving for, and we're actually going to isolate. We're going to isolate this, and it equals 1. We're going to isolate it by dividing both sides by secant y squared. So we are going to end up with dy by dx is 1 over secant y squared. Well, now what do? Because we have a y in the denominator, and we don't want a y in the denominator. Well, we're going to go all the way back to this. We know that tan y is x. Well, what does that mean? Tan y is x over 1. But tan also equals opposite over adjacent, if you think back to the unit circle and to elementary functions. Well, that means we have 2 lengths of a triangle. Well, let's draw that triangle, shall we? We can draw that triangle. We can draw that triangle right here. and we can draw the lengths, and we can get the length we don't have. And when we get the length that we don't have, we can solve our equation. Well, opposite is x. Opposite our angle is x. And adjacent is 1. So we're looking for this right here. We're looking for the hypotenuse length. And we know that that's going to be the square root of x squared plus 1 squared, which is 1. Okay, well, using this triangle, what do we know? We know that secant y is actually going to be the reciprocal of cosine. Well, cosine is adjacent over hypotenuse. So we know that secant is hypotenuse over adjacent. Well, what is hypotenuse? The hypotenuse is the square root of x squared plus 1. And the adjacent is just 1, so we just have the root of x squared plus 1. Well, let's just plug it in, and then we already have our solution. Now we know that dy by dx is 1 over x squared plus 1 squared, because we're just pulling that out by this power rule right here. If you can't remember, let me just write it really quickly. Is the same as a to the n over b to the n. So we're just pulling out that square, and then we're going to square the entire thing. We're just going to square the entire thing, and we end up with 1 squared, which is 1, over x squared plus 1. And that's our solution. And in the next video, we're going to derive our cotangent x. But just to say it in this video already, it's just going to be the negative version of the derivative of tan, arctan x. Cotangent x is just going to be this with a minus in front of it. So stop by and watch that one.